there is a potential problem with using an extension on a 1900 box. National Electrical Code Section 408.20b states that a switch shall not be used as a service disconnecting means for equipment required to be supplied by more than one source of supply. National Electrical Code Section 408.15 requires that the means for disconnecting the supply shall be rated for the application. A 1900 box is a service entrance box that is designed to provide a single point of disconnect for the electrical service to a building. When an extension is used on the 1900 box, it creates a situation where there is more than one point of disconnect. This can be a safety hazard, as it could allow someone to inadvertently disconnect the power to the building by opening the extension while the main breaker in the 1900 box is still on. To comply with the National Electrical Code, a separate service disconnecting means must be installed in conjunction with the extension. This disconnecting means must be rated for the application and must be located in a readily accessible location. The inspector was correct to reject the installation without the code reference because it violates National Electrical Code Section 408.20b and 408.15a. To resolve the issue, a separate service disconnecting means must be installed in accordance with the National Electrical Code. This could be a circuit breaker or a fuse disconnect switch. Let's delve deeper into the specific code sections mentioned and explore why they are relevant in this scenario. National Electrical Code Section 408.20b focuses on preventing the use of a switch as the primary disconnecting means when multiple power sources are involved. In the context of a 1900 box extension, this is crucial because the extension could introduce an additional point where the power can be interrupted. Imagine a scenario where someone believes they have to energize the circuit by switching off the extension while the main breaker within the 1900 box remains active. This creates a dangerous situation where live conductors are still present, posing a risk of electrical shock or arc flash. The code aims to avoid such confusion and ensure a clear and reliable method for completely disconnecting the power supply. Now let's turn our attention to National Electrical Code Section 408.15a. This section emphasizes the importance of proper rating for the disconnecting means. The disconnecting means, whether it's a circuit breaker or a fuse disconnect switch, must be capable of safely handling the maximum current that the circuit is likely to carry. Using an undersized disconnecting means can lead to overheating, premature failure, and potentially even a fire hazard. When an extension is added to a 1900 box, it's essential to reassess the overall load on the circuit and ensure that the existing or newly installed disconnecting means is adequately rated. Failing to do so can compromise the safety and reliability of the entire electrical system. Let's explore some practical solutions to address the issue of using an extension on a 1900 box while adhering to the National Electrical Code requirements. Firstly, consider replacing the existing 1900 box with a larger enclosure that can accommodate all the necessary connections and provide a single, code-compliant disconnecting means. This eliminates the need for an extension altogether and simplifies the wiring configuration. However, this option may involve more extensive modifications to the electrical system and may not be feasible in all situations. Secondly, if replacing the 1900 box is not an option, installing a separate service disconnecting means in conjunction with the extension is a viable alternative. This involves adding a dedicated circuit breaker or fuse disconnect switch that is properly rated for the circuit's load and is readily accessible. The disconnecting means should be installed in a location that is easily identifiable and clearly marked, ensuring that anyone working on the electrical system can quickly and safely de-energize the circuit. When choosing a circuit breaker or fuse disconnect switch, it's crucial to select one that is specifically designed for service entrance applications. These devices typically have higher interrupting ratings and are built to withstand the rigors of continuous operation. Consult with a qualified electrician or electrical engineer to determine the appropriate size and type of disconnecting means for your specific installation. In addition to the technical considerations, it's also important to address the aesthetic aspects of the installation. Ensure that all wiring is neatly organized and properly supported, and that all enclosures are securely mounted and labeled. A professional-looking installation not only enhances the safety and reliability of the electrical system but also demonstrates a commitment to quality workmanship. Remember that electrical work can be dangerous, and it's always best to consult with a qualified electrician if you're unsure about any aspect of the installation. A licensed electrician has the knowledge, skills, and experience to ensure that the work is done safely and in accordance with the National Electrical Code. Furthermore, it's essential to obtain all necessary permits and inspections before starting any electrical work. This ensures that the installation meets all applicable codes and regulations and that it is safe for use. Local building codes and regulations may vary, so it's important to check with your local authorities to determine the specific requirements in your area. Failing to obtain the necessary permits and inspections can result in fines, delays, and even the removal of the non-compliant installation. The National Electrical Code is a comprehensive set of standards that are designed to protect people and property from electrical hazards. By following the code requirements and best practices, you can ensure that your electrical system is safe, reliable, and code compliant. Understanding the principles behind the code is just as important as knowing the specific rules. The code is constantly evolving to address new technologies and changing conditions, so it's important to stay up to date on the latest revisions. There are many resources available to help you learn more about the National Electrical Code, including books, online courses, and seminars. Consider attending a code update class or subscribing to an electrical industry publication to stay informed about the latest changes and interpretations. In addition to the National Electrical Code, there may be other applicable standards and regulations that you need to consider. For example, the National Fire Protection Association, or NFPA, publishes a number of standards related to electrical safety, including NFPA 70E, which covers electrical safety in the workplace. It's important to be aware of these other standards and regulations and to comply with them as applicable. Electrical safety is a shared responsibility, and it's important for everyone to do their part to prevent electrical accidents. This includes homeowners, electricians, inspectors, and manufacturers. By working together, we can create a safer electrical environment for everyone. Remember to always de-energize circuits before working on them, to use properly insulated tools, and to wear appropriate personal protective equipment. If you're not comfortable working on electrical equipment, it's always best to call a qualified electrician. Electricity is a powerful force, and it's important to treat it with respect. By following the safety guidelines and best practices, you can minimize the risk of electrical accidents and protect yourself and others from harm. Let's recap the key points discussed. Using an extension on a 1900 box can create multiple disconnect points, violating National Electrical Code sections 408.20b and 408.15a. This can pose a safety hazard, as it could allow someone to inadvertently disconnect the power to the building by opening the extension while the main breaker in the 1900 box is still on. To comply with the National Electrical Code, a separate service disconnecting means must be installed in conjunction with the extension. This disconnecting means must be rated for the application and must be located in a readily accessible location. The inspector was correct to reject the installation without a code reference because it violates National Electrical Code sections 408.20b and 408.15a. To resolve the issue, a separate service disconnecting means must be installed in accordance with the National Electrical Code. This could be a circuit breaker or a fuse disconnect switch. Consult with a qualified electrician to determine the appropriate size and type of disconnecting means for your specific installation. Obtain all necessary permits and inspections before starting any electrical work. Follow the National Electrical Code and other applicable standards and regulations to ensure that your electrical system is safe, reliable, and code compliant. Electrical safety is a shared responsibility, and it's important for everyone to do their part to prevent electrical accidents. By following these guidelines, you can help ensure that your electrical system is safe and that you and your family are protected from electrical hazards. Furthermore, consider the long-term implications of your electrical installations. Choose high-quality materials and components that are designed to last and withstand the rigors of continuous use. Proper maintenance and periodic inspections can help identify potential problems before they become serious and can extend the lifespan of your electrical system. Investing in energy-efficient electrical equipment can also save you money on your electricity bills and reduce your carbon footprint. Look for appliances and lighting fixtures that are Energy Star certified and consider installing a smart thermostat to optimize your energy consumption. Educate yourself about electrical safety and share your knowledge with others. Encourage your family members, friends, and neighbors to learn about electrical hazards and how to prevent them. Together, we can create a safer and more energy-efficient electrical environment for everyone. Remember that electrical work is not a DIY project. Always consult with a qualified electrician for any electrical work that you are not comfortable doing yourself. A licensed electrician has the training, experience, and tools to ensure that the work is done safely and correctly. Don't take chances with electricity. Your safety and the safety of others depend on it. In addition to the specific issue of using an extension on a 1900 box, it's also important to be aware of other common electrical code violations. These include overloading circuits, using damaged or frayed wiring, and failing to properly ground electrical equipment. Overloading circuits can cause the wires to overheat and potentially start a fire. To prevent overloading, avoid plugging too many appliances into a single circuit. Use a circuit breaker finder to identify the circuits in your home and to determine the load on each circuit. If you notice that a circuit breaker is tripping frequently, it's a sign that the circuit is overloaded and needs to be addressed. Damaged or frayed wiring can expose live conductors and create a shock hazard. Inspect your wiring regularly for any signs of damage and replace any damaged wiring immediately. Never attempt to repair damaged wiring yourself. Always call a qualified electrician to do the repair. Properly grounding electrical equipment is essential for preventing electrical shock. Grounding provides a path for fault current to flow back to the source, tripping the circuit breaker and energizing the circuit. Make sure that all of your electrical equipment is properly grounded and that the grounding connections are tight and corrosion-free. If you are not sure whether your electrical equipment is properly grounded, consult with a qualified electrician. Staying informed about electrical safety and code compliance is an ongoing process. The National Electrical Code is updated every 3 years, and there are always new technologies and best practices to learn about. Take the time to educate yourself and to stay up to date on the latest developments in the electrical industry. Your safety and the safety of others depend on it. To further illustrate the importance of code compliance, consider the potential consequences of violating electrical codes. These consequences can range from minor inconveniences to serious injuries or even death. A minor code violation, such as using an undersized wire, might simply result in a flickering light or a malfunctioning appliance. However, a more serious code violation, such as failing to properly ground electrical equipment, could result in a fatal electrical shock. Electrical fires are another potential consequence of code violations. Overloaded circuits, damaged wiring, and improper grounding can all contribute to electrical fires. These fires can spread quickly and cause significant damage to property and can even result in loss of life. In addition to the physical dangers, code violations can also result in financial penalties. Building inspectors can issue fines for code violations, and insurance companies may deny claims for damages caused by non-compliant electrical installations. Furthermore, code violations can create legal liabilities. If someone is injured or killed as a result of a code violation, the responsible party may be held liable for damages. In conclusion, electrical code compliance is not just a matter of following the rules. It's a matter of protecting people and property from electrical hazards. By understanding the code requirements and best practices, you can help ensure that your electrical system is safe, reliable, and code compliant. So, the next time you're working on an electrical project, remember to prioritize safety and to follow the code. It's the best way to protect yourself and others from the dangers of electricity. And don't hesitate to consult with a qualified electrician if you have any questions or concerns.